Hello, my name is Ashley Goodnight, and this is my Week 10 reading review for Physics 2212. This week, all of the EDX videos related to the main concept of Faraday's law. The videos had three main topics. First, there was an introduction. Second, we looked at induced currents. Third, we discussed the force on a magnetic dipole. Let's get into it. The first video introduced Faraday's law, which is responsible for many things in everyday life, including credit cards and electric instruments. Throughout all of these EDX lectures, we used the example of a falling magnet. By calculating the magnetic flux on a surface over time, we found that as time passes, the magnet gets closer and the B field increases, which increases the magnetic flux. We can take the derivative to solve for this rate of change. Basically, with Faraday's law, we know that the time-changing B fields produce curly E fields. Also from Faraday's law, we can integrate around a closed path. It's worth noting that the negative sign in the equation tells us how to get the direction of the E field. Moving on to the second video about Faraday's law, we take a look at the units of the equation. Volts. The actual equation calculates the magnitude of the EMF. Going back to the example of the falling magnet, we wrap a wire loop around the observed surface. We know that the current will flow in the direction of the curly E field. We call this current induced by the change in magnetic flux. This second video goes on to discuss Lenz's law, which dictates that a magnetic field from induced currents opposes the change in flux. We also learned that in order to achieve an induced current, you need a conductor. No conducting loop, no induced current. Finally, the video discussed power and EMF with the main physics concept of conservation of energy. On to the last video, we answered the question, what's the force on the falling magnet due to the current loop? We found an equation to solve for the force at one observation location, but since all of the y components are the same around the loop, we can replace delta L with the loop's circumference to simplify the equation. This week's lecture videos closed out with a discussion on the prediction, the magnetic's motion with Newton's second law, which utilizes all of the following equations. This week's lessons apply directly to my major, electrical engineering. At Georgia Tech, EE majors select fields or threads to specialize in. Two in specific, telecommunications and circuit technology, have required courses that build off what we're learning in this class. Those who follow telecommunications take ECE 4350, electromagnetic and microwave applications, while students studying circuit technology take ECE 4391, electromagnetic compatibility. That wraps up my introduction to Week 10. Thank you for listening.